Hello, welcome again to my YouTube channel, and we have here another tutorial on open rectangular channel. As I said earlier on, kindly subscribe, comment and share my YouTube channel so that we can impact as many people as possible who could be having challenges with these particular questions. Our question read, a rectangular channel with a bottom width of 4 meters and a bottom slope of 0.008 has a discharge of 1.5 cubic meter per second in a gradually varied flow, which is GVF in this channel. The depth at a certain location is found to be 0.3 meter. Assuming N is equivalent to 0.016, determine the following: the normal depth Yn, the critical depth Yc, and type of gradually varying flow profile. Now, let us start with the normal depth Yn. So step number one, as I said earlier on, you have to sketch the rectangular channel. We've been told that it has a bottom width of 4 meters. So remember, width in channel, we call it small letter b. So b is equivalent to 4 meters. Now, our normal depth, Yn, is the unknown. Now, from the question here, we've been given, you see here, given q is equivalent to 1.5, then bottom slope is equivalent to, we denote it as S naught is equivalent to 0.008, and then Manning's coefficient, which we call it N, is given as 0.06. Now our question is why N is equivalent to what? Now we have to compute for the value of Yn, normal depth. Now step number one, we'll have to come and say, we know that from Manning's equation that Q is given by, the discharge is given by 1 over Manning's coefficient multiplied by area power 5 over 3 divided by weighted perimeter P power 2 over 3. Currently note this is P power 2 over 3 multiplied by the bottom slope power a half, or multiplied by, you can say, square root of bottom slope. So now the area for a rectangular channel, area is equivalent to BYN, B times YN, which is, now B is 4, Yn is unknown, so it will remain to be 4Yn. Weighted perimeter, as we said earlier on, we said weighted perimeter is simply the parts of a channel in contact with water. So if our water level is here, it means the weighted perimeter is the sum of this, the sum of that, and that will be a weighted perimeter. So this will imply that basically it means our weighted perimeter is B plus 2Yn, which is B plus Yn plus Yn. So we just say B plus 2Yn, which will be 4 plus 2Yn. Now from there, we can now substitute in our Manning's equation and say 1.5 is equivalent to 1 over 0.016. You multiply by area is 4Yn. So area power 5 over 3, which is 4Yn power 5 over 3 divided by P power 2 over 3. Our P is 4 plus 2Yn. We multiply it by power, we raise it to power 2 over 3. We multiply by our bed or bottom slope is 0.008, which is power a half. So after that, what we'll do, we will take the constants to the left-hand side and variables to the right-hand side. So if I take constant to the left-hand side, I mean this 1 over 0.06, I multiply by 0.008 power half. Then the result I get, I take 1.5 divided by this result. So you find like it will be 0.849 is equivalent to 4Yn. Now we only remain with 4Yn power 5 over 3 divided by 4 plus 2yn power 2 over 3. Now when we reach this particular point, it means for we to compute the value of yn, you find a value, a single value. When you put it in the numerator and denominator, the result on the right-hand side will be equivalent to 0.849. So now we have two widely known methods. We have Excel solver in Microsoft Excel, or you can do by trial and error method. So for this particular case, let me teach you how to do it by trial and error method. Now I will come up with a table and write yn, this yn, y normal, then left-hand side and right-hand side. Now for the left-hand side, it is constant 0.849. You just fill it 0.849, 0.849, 0.849. But now the right-hand side depends with the value of yn. Now take an example. If I take a yn of 0.2, so it means I will come on my right-hand side. Where there is yn, I put 0.2 in the numerator and 0.2 in the denominator. So if you compute by your calculator, you will find that the right-hand side, the result here will be 0.257. But now, our aim is to get 0.849. So 0.257 is way below 0.849. So I will move to another higher value. Let's say I take 0.4. So if I replace yn by 0.4 in the numerator and 0.4 in the denominator and compute with my calculator, I'll find that on my right-hand side, I will end up with 0.769. 0.769 is still below 0.849. Maybe let me move now to 0.6. I've taken an interval of 0.2. So if I take a value of 0.6 and I replace where we have yn by 0.6, I will end up with my right-hand side being 1.433. Now, 1.433 is way above 0.849. It's very big than this. So it will mean automatically the value of yn lies between 0.4 and 0.6 meter. Now, after computing, I found out that the value of yn of 0.43 meter, it will make the right-hand side be equivalent to 0.849, which is the left-hand side. So our normal depth is equivalent to 0.43 meter. This is by trial and error method. Then now we go to critical depth. Now our critical depth is given by small q squared divided by g power a third. Now remember, small q, we call it unit discharge. Unit discharge is given by discharge divided by bottom width or width of the channel. This is small q is unit weight, which is now 1.5, which is the total discharge, divided by 4, which is the breadth or width. So you find it is 0.375 meter square per second. Now, to avoid confusing meter square per second with acceleration, you can write 0.375 cubic meter per second per meter. So you write it as cubic meter per second because of Q, then per meter because of B. Now, Y critical will be equivalent to small q squared, 0.375 squared divided by 9.81 power a third. Remember, G is gravitational field strength. We know it is 9.81. So you find our critical depth is 0.243 meter. Then the last question is type of gradually varied flow profile. Now what to consider is, first of all, you have to consider our normal depth is 0.43. Our critical depth is 0.243. And our depth at that point we are considering is 0.30. So if you look at that, you find like our depth for that section lies between the normal depth and the critical depth. So we'll call it zone 2. So the type of flow profile is zone 2, whereby our depth is between the normal depth and the critical depth. Thank you very much. See you soon.